Hi, my name is Junyan Chen. Today, I'm going to introduce some mathematical methods in the Renaissance, uh, and it's mostly about perspective. I'm going to introduce the perspective from three aspects. The first is math in painting. The second is methods using perspective. The third one is influences in the future. So, at first, people do not use perspective a lot. When do people start to focus about perspective? That's that's the Renaissance. Um, and the aspects people focus about them are painting, drawing, and architectures and sculptures, and some other visual arts, and some visual arts. If you have took the course Art 203, which is visual arts, you might know what am I going to say following. Uh, so let's look at those two kinds of perspective. The one on the left is called one-point perspective. We can see that there are a lot of red lines on the drawing, and they all intersect at one point. This point is called the vanishing point, and because there is only one vanishing point on the painting, so we call it one-point perspective. Uh, Observing the picture on the left, we can find out that actually those two sofas are at the same size, but why the one on the right looks bigger than the one on the left? That's because perspective. Um, because normally, imagine if you are standing at a point, uh, the thing closer to you looks bigger than those things uh, further to you, right? Okay, the pictures on the right uh, are called two-point perspective. So let's first look at the picture on the bottom. Um, this picture looks very detailed, so I extracted the picture uh, out, and we get the picture above. Uh, it's like a cube, and if we have some vanishing line, we can find out that those lines uh, intersects at 2 points, and those 2 points are on a same horizontal line. This kind of perspective is called two-point perspective. And that's because when people standing at a point and facing at a thing really close to him, then things further, no matter from the left or from the right, will look way much smaller. And that's why we have one-point perspective and two-point perspective. So um, that's more close to art. However, we will soon see that actually that's a math problem. Okay, but before that, I'd like to introduce some other things so we can know perspective more clearly. Uh, Comparing those two pictures on the left, we can find out that the picture above uh, is the one that didn't use perspective. So we can find out that everybody on the picture looks are the same size, and the buildings are the same size. The whole picture, if we look them parts by parts, we can get really clear information. However, if we look at this picture uh, in a whole, we can not get a sense of reality. So the picture above lost a sense of reality. People during the Renaissance also realized that, so they start to think about, oh, how can we make our pictures and sculptures look more reality? Then they developed the perspective. The picture on the bottom is a famous painting by Leonardo da Vinci, and it's called The Last Supper. Observing this picture, we can find that uh, the paintings on the left wall and the paintings on the right wall, actually they are at the same size. But if we line up these sides of the paintings, we can find out that uh, they vanish at the same point, which is behind Jesus, the window. So that's a really different painting at that time because it used perspective. And Leonardo da Vinci is one of those pioneers, one of those masters who started using perspective. Okay, then it's the influence in the future. Okay, the the development of perspective made a great base for projective geometry. However, perspective was developed in around 15th century. However, projective geometry was invented in 18th century. As uh, a long time period. However, without the development of perspective, we might not see projective geometry even today. Perspective is really important for projective geometry. So what is projective geometry? It's about one important thing, which is projection. We can look at those pictures under the sentence. So let's look at the first picture. Um, there is an eye on the left, and we draw some lines from the eye uh, passing the triangle on the vertical plane, and then we end the line on the horizontal plane. Um, According to our reality experience, the triangle on PP plane, which is the vertical plane, might be the real triangle. And the plane on RP plane, uh, and the triangle on RP plane might be the projective triangle. How did we get those different triangle and how did we connected them? So we just have have those lines starting from the eye, and we end at the same plane, and we end those lines at one same plane, and we line up them. Then we get a projective triangle. How are they connected? As you can see now, the triangle on PP plane and the triangle on RP plane are totally different. However, if we now we are looking at the whole system on the left of PP plane. If we move our eye if we move our eye onto the upside of RP plane, we will get a same view when we're looking at PP plane from the left side of PP plane. That is projective geometry. This might sound a little bit abstract. Let's look at the picture on the right. It's more direct. So it just replaced the eye into a lamp, and it has many light lines passing through those triangles, and they have some shadows on the same plane. Those shadows are the projections of those triangles on the plane. Way much clearer, right? Actually, we started contacting projective geometry since we were very young, like in primary school. However, we didn't realize that they are projective geometry at all at that time. Here is a coordinate system. Now what we are looking at is a three-dimension coordinate system. As I mentioned before, we have contacted projective geometry since we were very young. Okay, how? Now let's not look at the z line. Let's just look at x line and y line and the OP. As we learned before, if the coordinate of P is 1, 1, then it means when we make an orthogonal line from P to X line, intersecting X line at PX, then the length of OPX is 1. The same thing works on the Y line. So actually, OPX is exactly the projection of OP on X line. The same thing happened even in three-dimension coordinate system. Then, so first we make an orthogonal line to XZ plane from P. Then we can get a line which is OR. Let's call this point R. So OR is the projection line of OP on XZ plane. And then let's not look at Y line. The thing left is just a two-dimension coordinate system. So the same thing can happen. So we know that P, the coordinate of P is 1, 1, 1, which means the length of the projection of OP on X line is 1. The length of the projection of OP on Y line is 1. The length of projection of OP on Z line is 1. That's how we have coordinate system. So we can even say that without projective geometry, we might not even have coordinate system. So perspective helped inventing projective geometry, and the projective geometry helped inventing coordinate system. So we can even say that without perspective, we might not even have a coordinate system. That's really an important thing happened in the Renaissance. Okay, I guess that's all. Thank you. Bye-bye.